What's up, everyone? How we doing? Pretty good? Friday, 10 a.m. So we purposefully asked for this slot because we know only the die-hard networking folks would come on a Friday at 10 a.m. So, I mean, this is a great community, and I'm glad to be a part of it. I'm Matt Lewis. I'm a senior principal in EC2. This is actually the 10th year I'll be at reInvent. It's my 10-year anniversary at Amazon as well as a few weeks ago. 8th year, I think, doing this session. Alex has joined me for the last couple of years. So Alex is a principal solution architect for our strategic account, networking specialist, an amazing networking wizard as well.
Thank you. Thank you. Thank you all for joining us today. I'm honored and humbled by the numbers, so thank you.
It really helps when next year comes around and we spend hundreds of hours in PowerPoint and designing stickers, and it just makes it all worthwhile. So.
For sure.
All right, so we've got a lot of content, so we're going to get right in there. This is the title slide, and away we go. So before we begin, this is a 300 level session. It's not a 200 level, it's not a 400 level, but that means we have to balance. We have to balance between foundations and deep technical things. So 300 is kind of that middle point. So there's some folks in here that might not know what a VPC is, maybe, or there's folks here who are more experts than us. So we try and straddle that line. We'll throw in a couple of photo icons. I know folks love to take photos. This session is recorded. It will be on YouTube. Hi, Mum. How you doing? And so you can check it out after the fact, and please do. So we're going to go pretty quickly through some of these builds, so don't be disappointed if you don't get a snap. It'll be on YouTube. And lastly, this year, we have the AWS CAT networking wizard who will be sprinkled throughout. Hope you all got a sticker. If not, come and see us later. And there's a cool CAT IPv6 sticker that we threw in there for good measure this year too. So the idea of this session is really to talk about our services and features around networking. Then we want to talk about our new capabilities. So what have we done in the last 12 months? Then we want to dive into deep advanced architectures. So things that you might build where you'll combine some of the features and services together into one. So that said, again, I said I was going to go pretty quick here because we've got a lot of content. Let's talk about the foundations. Okay, so EC2 Classic back in 2006, it kind of looked like this. But then, I think it was around 2010, we released Amazon VPC. It was designed to be kind of like your pseudo data center or virtual data center in the cloud. We thought every customer would have one. We turned out we were wrong. But inside the VPC, we have intra-VPC components, so things like subnets, things like availability zones. A VPC is a region-level construct. Subnets are availability zone constructs. EC2 instances are availability zone constructs. They're all part of the region itself. A VPC, if someone says, hey, what is that? I say, well, it's kind of like a private space, but it's basically a VPC CIDR, either V4 or V6. And so you'll designate CIDR or subnets to, or subnet addresses to your subnets, either V4, dual stack with V6, or V6 only, which is actually kind of cool. We also have this thing called an internet gateway. It gives you internet access, an egress-only internet gateway for V6. And inside the VPC, you have this thing called a route table. And the route table basically directs traffic, pretty straightforward. And so you have things like elastic IPs, you can talk to public services, you can talk to the internet, you can have private subnets that don't talk to the internet, and maybe they'll talk to things like gateway endpoints privately. You'll notice we really like these gateway things. We bolt those onto the VPCs, and we've been developing these services as we go. Network firewall, we'll dive into that. Gateway load balancer, a mechanism for you to build your own firewall, egress security VPCs, application load balancer, network load balancer for inbound traffic. I did say I was going to go fast. VPC Lattice, which is a new service we released last year, was it? Or actually GA this year. So an amazing service where you can register services with a service directory, and you build this thing called a service network. Alex is going to do a deep dive on that, so that's going to be really interesting. Service endpoints to talk to public services, maybe private services that you build. Again, gateway load balancer endpoints. Connecting to the VPC, VPC peering. I'll slow down in just a second. We have cross-region VPC peering, transit gateway, which released in 2018. Amazing service, 5,000 VPCs connected to one transit gateway in each region. Or you can peer transit gateways together across regions. Or you could replace those transit gateways with Cloud WAN, or use them together. And so you can deploy Cloud WAN globally. We can do VPN connections, direct connect, physical fiber to AWS, connected to transit gateways if we want to. Transit Gateway Connect. Customers wanted to bridge their SD-WAN deployments into AWS, and so Transit Gateway Connect was one thing we built for that. Also, of course, we can connect Cloud WAN to Cloud WAN Connect, just like for your SD-WAN headends, and Direct Connect and VPN for Cloud WAN. We're almost at the end of the foundations, and then we'll all be on the same level, hopefully, fingers crossed. We can do VPN, client VPN connections, instance connect, so connecting to instances within your environment via the AWS console. And then lastly, AWS verified access, so our zero trust front end to applications within the VPC. So the big question is, can we fit all of that onto one slide? The answer is absolutely yes. And here it is. Here's the photo slide. This slide was a doozy. I'm glad you folks like it. Okay, let's move on. Alex, over to you for IP address management.
Well, so we want to build all those things, right, that we just showed on the previous slide. But for that, we need to start doing things the right way, right? And we need to start with IP address management. And Matt talked about the capabilities of deploying. We thought initially that everyone's going to have one VPC. We were wrong. Customers do have multiple VPCs, sometimes a lot of VPCs, and that means a lot of IP address management. But why is it so important? Well, because there are a couple of things that a good IP address management scheme and mechanism enables you to do. First, we're all battling public IPv4 exhaustion, and understanding how you're using public IPv4 addresses and how you can optimize that is powered by a very good IP management tool. Then private IPv4 exhaustion. Very large enterprises are saying, well, we're running out of our RFC 1918 space. Well, sometimes, a lot of the times, that happens because IP management. Cost optimization. How you can adopt technologies like IPv6 for cost optimization or for scale, how you can minimize your cost spent driven by poor addressing scheme decisions, IP management again. And last but not least, global expansion. Think of starting to deploy your global infrastructure in more AWS regions. Those need to start with VPCs, right? And you need to start with connectivity powered by IP management. We have a tool for that. It's called Amazon VPC IPAM, and it allows you to do IPv4 and IPv6 management at scale, right? It allows you to tap into historical insights for your IP addresses. It allows you to implement your own business logic into how you assign IP addresses, and of course for both IPv4 and IPv6. We talked a bit about IPAM last year as well. But there's a couple of new launches that we want to review for this year. First, you can integrate IPAM with accounts outside of your organization. This has been a very long-standing ask from our customers because there's things like mergers and acquisitions, right? And you can now gain detailed insights into your IP address utilization metrics. And I'm very excited about this console in IPAM that shows you exactly where your IP addresses are being used, how many VPCs are compliant, how many VPCs have overlapping IP space, how many are managed and not managed. And it also gives you very detailed insights. It gives you very detailed insights into what your top subnets from utilization perspective are, what your top VPCs from utilization perspective are. So very cool dashboards. Now, there's a great news also from IPAM. We always try to make the right things for our customers in terms of powering them to use the tools that they need at an optimal cost point. So Amazon VPC IPAM just launched free tier. You have access to all the goodies in IPAM in a region, in an account. So you can use it to configure and to manage your IP space. It allows you to bring your own IP as well on a per region and per account basis. And it also enables you to get IPv6 addresses, CIDRs, contiguous CIDRs from Amazon. This is a very important thing for customers adopting IPv6. The reason for that is because it allows contiguous addressing. And we talked a bit about how important it is to understand your public IPv4 address utilization. Part of IPAM and part of IPAM free tier is public IP insights, cross-region, cross-account support. So you can go into public IP insights and you can see what types of addresses you're using, where you're using them, right, and why. Public IP Insights also has a very cool console. It shows you by public IP address type how you're using these addresses. And it also gives you a lot of information related to security groups, network interfaces to which those public IPv4 addresses are associated. So it gives you the tool to make sure that you have the right information to optimize. Now, a very important thing I mentioned about IPv6 addressing is summarization. You will ask, well, why is that? Well, in IPv4, you could easily summarize private IPv4 space in RFC 1918 routes, right? In IPv6, it's no longer that. You have global unicast addresses on AWS. You configure them in VPCs, and if they're not summarized, your route tables are going to be very large. So in IPAM, you can go and you can configure, you can get from Amazon a contiguous CIDR per region in your account to address all the VPCs that you have there with that contiguous space, which is dramatically simplifying your routing. Another very important IPv6 launch that happened this year is the ability to tier your IPv6 addressing in the VPC. By default, we have VPCs that were /56 and subnets that were /64. We now have the capability of choosing the size of the CIDR for the VPC and the size of the CIDRs for the subnets. And one very important feature that we're going to see a bit later, what powers, is the primary IPv6 address on an interface. So think of the fact that you have an EC2 instance, and this EC2 instance has its elastic network interfaces. IPv6 addresses, the first IPv6 address that you associate, can now be configured as primary. We have the foundation. Now let's start building.
Thanks, Alex. Okay, so let's talk about some VPC networking things. This is chapter 3 of our session here today. There's two main ways we think about VPC and networking. One is extending the VPC boundary, and the other is connecting to the VPC itself. So there's really these two different ways you can think about connecting. And really, networking is about connecting applications together. It's about routing. So first, we have VPC sharing. Now, the idea behind VPC sharing was really we wanted networking folks to be able to control and build an environment, VPCs, subnets, et cetera, and have other accounts, other principals come in and deploy infrastructure or applications inside that VPC. Now, VPC sharing is something that a lot of customers are utilizing these days, where you can deploy Lambda or EC2 and others inside someone else's VPC. The great thing is, as a owner of a VPC, and when you're sharing that VPC out, you have control over things like the IGWs, over the route table, over the endpoints, and the participant of that VPC does not. So you still kind of maintain some of that control. So the big question is, do you expand your VPC by using things like VPC sharing or grow the size of your single VPC? Some customers do. Or do you create more VPCs, create 10, 100, 1,000? There was a customer this week that said, I think they had in excess of 4,000 VPCs in their deployment. That's one way to go too. Now, it's not really an or question. This is really an and question. You can do both. And so if we just compare the two together, individual VPCs or single VPCs, or in a large case, what we call a hyperscale VPC, basically you've got a distributed, if you have individual VPCs, you've got a distributed network of VPCs. With a shared VPC, you could have a hyperscale VPC or a single VPC. And so we have this unit of measure inside of VPC called an NAU, or a network address unit. We talked about it a little bit last year, where basically one IP address consumes an NAU. You can have up to 256,000 in-use IPs inside a single VPC, 512 in a shared VPC. So if you go down the shared VPC route, you have to think about NAU consumption. With going down the individual VPC route for each application and having many VPCs, you need to connect them together. And so if you think about having many VPCs, you're lowering that scope of impact. If someone misconfigures a route table inside a VPC, one application is affected. If you've got a shared VPC and someone misconfigures a route table, you've got a larger domain there to consider. Now, this year we did also release a feature that plays directly into the multi-VPC realm, where you can now have an elastic network interface that is or have an instance that is multi-VPC attached. So an elastic network interface in another VPC. This is still in the same AWS account and still in the same availability zone, but this is actually a great feature for folks that want to have that instance and drop it into another VPC without having to manage peering or transit gateways, etc. Okay, so connecting to the VPC, we have a whole bunch of different mechanisms. The first, internet connectivity. We've got an interesting architecture at the end of this small section. But basically, inside the VPC, you've got your availability zones and public subnets, routing. You talk to an internet gateway, or maybe an egress-only internet gateway if you're V6. You have private subnets. You might use a NAT gateway to talk to the internet through a NAT gateway. But again, it all comes down to routing on a per subnet basis. Now, if we talk about NAT gateway specifically here, this year we also released the feature where you can have now up to 8 IP addresses associated with a NAT gateway, and we'll actually flow hash traffic across those IP addresses. Why would you want that? Well, originally a NAT gateway could have one address, and one address means 55,000 concurrent connections through a NAT gateway. Now we've got 8 times that. I think the number's 455,000.
Yes.
Concurrent connections over the 8 IPs. So this is something that customers wanted to scale their NAT gateway deployments. Pretty cool stuff. Okay, we've also got NAT gateway in a local zone. I did work on the Outposts service team for a little while, and it was actually a very exciting time. One of the tenets we had on that team was we want the same experience in local zones and Outposts as the region. And so what we're doing is we're trying to bring all those services to local zones. So in this case, we've actually now got NAT gateway available in the LA local zone. And so hopefully we can see more and more services deployed in local zone in the future. And here's this interesting architecture I was talking about. We have some customers that use V6. That's great. And they use the IGW as an interconnectivity mechanism between VPCs instead of using transit gateway or instead of using peering. And that's okay because they don't need NAT. So in this case, you could have hosts within a VPC talking to public services or talking from an IGW to an IGW. Or there might be one-way communication or inside initiated communication from a host out an egress IGW or a eIGW. Or it might talk via a IGW to another VPC. So in this case, they're basically using the IGW as a transit gateway. And with V6, that works because they're all public addresses. So it's quite easy to do. Okay, so the next connectivity mechanism is AWS Private Link. And for the longest time, this was one of my favorite services because it was, when we released it, it was the ability for you to take services and drop them into other people's VPCs, or you consume services from other people's VPCs. The first use case, though, was what we call interface endpoints for service connectivity, where we basically enabled private connectivity for all of these public services into the VPC. We started with about 30 services. We've now got 150 plus services that you can talk privately to via interface endpoints in your VPC. You can also, with Private Link, a few more details here. A Private Link interface endpoint actually has 2 elastic network interfaces inside the VPC in 2 different subnets, and they'll actually consume IP addresses inside your VPC. And so here we've got a topology where we've got Private Link also communicating with services in another VPC. Now, what we've done this year is we're now giving you the ability to define those addresses. And so you can tell private link interface endpoints what specific IPs to use in your VPC. Again, it's your private range in your VPC, so more control over that is a good thing. Okay, connectivity with other VPCs. Take it away, Alex.
Thank you. Okay, so we scale, right? We start with our one VPC, and then we create more, either individual or shared, or a combination of the two, right? And then we figure out, well, we need connectivity, right? How do we do that? And we reviewed a couple of options. We're going to dive a bit deeper into them. The first one is VPC peering, and is the foundational connectivity option for VPCs. It's a one-to-one connection between two VPCs, and you can do intra-region VPC peering or cross-region VPC peering as well. One of the features that's most liked by our customers for VPC peering is the ability to use security group referencing. This means that in a security group associated with a resource in a VPC, you can actually add a reference for either inbound or outbound, a security group ID that is in that peered VPC. Very important to keep in mind the use cases for VPC peering and the fact that everything that we're going to talk about after VPC peering does not exclude the use of VPC peering. So you have to consider the fact that VPC peering is non-transitive, right? So it is a one-to-one relationship. You do have to consider the fact that you do need to configure routing, right? Security group referencing gives you that granular security access, but how does that scale, right? And if we dive a bit deeper and we scale, right, how do we do that? And here's where Transit Gateway comes into play. Transit Gateway gives you that routing hub centralized in a region to which you can connect thousands of VPCs, and you don't need to give up on VPC peering altogether, right? Transit Gateway has been released, I think, in 2018, right?
2018.
I think that was one of my most exciting reinvents. This is my 5th year. Now, from the connectivity perspective, Transit Gateway allows you to route both IPv4 and IPv6 at scale within a region. The constructs that Transit Gateway comes in with are attachments and route tables that enable you to segment, right? It automatically is able to automatically propagate the routes that it learns from the VPCs in those route tables. You can also configure static routes if you wish so. And you have the ability of creating that network segmentation, right? So you can choose attachments to Transit Gateway, the route tables to which these associate so that you separate your production environment from your development environment, for example. Now, I mentioned that you don't have to give up on VPC peering, right? You can use VPC peering and Transit Gateway, and we'll see that you can use Cloud WAN as well, right? In an architecture that powers your use cases, right? So let's look at the use cases, though. So why would you use both? High throughput, latency-sensitive communication, cost optimization. Absolutely, VPC peering gives you free intra-AZ data transfer costs, so use it wisely. Scalability, thousands of VPCs that need access to either hybrid connectivity or cross-region connectivity or SD-WAN connectivity, use Transit Gateway or Cloud WAN. And think of the fact that you can combine the two, right? And you can leverage the hierarchy of Transit Gateway routing and the optimized connectivity that VPC peering brings. And do take into consideration the scaling of both, right? And how to use both to power your use cases. Now, if we go into hybrid connectivity, we have Direct Connect, and Direct Connect is that dedicated connectivity that you can get from AWS. It's a physical connection that only you use, right? And it powers your data center to AWS routing and reachability. Now, we focused in the last year in getting closer to you. We have over 130 locations for Direct Connect to get closer to the place where our customers have data centers, right? But we didn't stop there. So with Direct Connect, you have multiple types of virtual interfaces. The first one is a private virtual interface, and this is the most foundational way which you can deploy Direct Connect. Then you have Direct Connect Gateway, which allows you to connect VPCs across multiple regions to the same Direct Connect virtual interface. We've released this year, or we've increased the quotas this year, and you can have up to 20 virtual private gateways per Direct Connect gateway from 10. You can also have a public virtual interface to access AWS public service endpoints. Make sure you secure it because it gives access to essentially everyone on AWS. You get the public IP addresses of AWS. And we have the native integration for Direct Connect with Transit Gateway through the Direct Connect Gateway and Transit VIFs. And this year, again, we've increased the quota to up to 4 transit virtual interfaces per Direct Connect connection, and up to 6 transit gateways per Direct Connect gateway. And I gave you a sneak peek into the following one. I think this is probably one of the most requested quota increases that our customers had. More routes advertised from AWS to on-prem. So you have now 200 as a combination between IPv4 and IPv6. And now we get to the very exciting part where we put all these things together, right? We take global connectivity to the next level with AWS Cloud WAN. We spoke about Cloud WAN probably in all of our sessions so far since we launched it. Cloud WAN gives you this global connectivity mechanism that allows you to leverage the AWS global backbone, private connectivity, right? Nothing goes over the internet. It allows you to also express your intent in terms of connectivity, and we're going to see how that intent is expressed through the Cloud WAN policy, and also gives you that single pane of glass for network visibility. There's a lot of exciting things that we can talk about that are coming in that space, so watch closely. Now let's look at the Cloud WAN components and recap them for what we can build with Cloud WAN. The first one is the core network policy, and that ability to express in JSON format what your intent is for network connectivity. And you start by saying, these are my autonomous system number ranges that the core network edges are going to be using. And then you specify the AWS regions where you want Cloud WAN to deploy. Then, this clicker. Then you specify the attachment policies. And we are going to see that every attachment to Cloud WAN is associated and propagated in a Cloud WAN segment based on these policies. Here is where you control your network configuration, and that is that single pane of glass. You can have multiple attachment rules. Cloud WAN makes use of core network edges in every region, and these core network edges are automatically paired with each other, and they exchange routes dynamically using Border Gateway Protocol, BGP. Each of these core network edges actually creates that transport, on top of which you can configure the network segments, which are your global route tables in a sense. You can choose if segments configured in Cloud WAN are global, so spanning all regions that are defined in Cloud WAN, or if you want region-local segments. This is actually a feature that a lot of our customers are using when they are dealing with regions and countries where they want data locality, and they want to ensure the fact that communication does not go outside of that region. Moreover, I was mentioning that each attachment is associated and propagated based on the attachment tag. This is different from the VPC tag. When you create an attachment, you have the option of specifying that attachment tag. Now, a very interesting thing is for Cloud WAN, you can define how you want attachments to be dealt with. Either Cloud WAN can automatically accept attachments, or you can configure, for example, a pipeline that does that acceptance. The interesting thing is that if you change the tag, Cloud WAN reanalyzes what the new tag is on that attachment and remaps your attachment to the right segment. So it's a continuous integration, continuous deployment mechanism for your network. Now, the VPC attachment makes use, again, of network interfaces, very similar to how transit gateway attachments work. You have to specify the Cloud WAN attachment subnets in your VPCs. And this is going to be very useful for new features that we've launched. From the VPC perspective, you do have to configure VPC routing. Cloud WAN does not automatically propagate routes that it learns within its segments to VPC route tables, because the VPC boundary as a network boundary gives you control over what you want to route in your VPC. The Connect attachment that Matt mentioned at the beginning, allowing customers to integrate natively SD-WAN appliances into the VPC and into their global network, makes use of a new attachment type, which is called the Connect attachment. You have to specify a transport attachment for the Connect attachment. On Cloud WAN, that transport attachment is a VPC attachment. So on top of that transport attachment, you create a Connect attachment, and on top of the Connect attachment, you create Connect peers. The default for the Connect peers encapsulation is GRE, generic routing encapsulation. Now, we've heard your feedback, and we released Tunnel-less Connect. This is cloud-enabled SD-WAN, native, without the encapsulation overhead of GRE tunnels. So it allows you to use natively the Cloud WAN interfaces in the VPC to peer BGP directly with Cloud WAN. So let's see how it works. We have the same transport attachment, we have the same Connect attachment, and we create the Tunnel-less Connect peers. Very important here is that each Connect peer has 2 BGP sessions for redundancy purposes. You can have both GRE and Tunnel-less Connect peers over the same Connect attachment. The Connect attachment and the transport attachment have to be part of the same route table on Cloud WAN, so production in our case here. And if SD-WAN appliances are deployed outside of the attachment subnet, you have to configure routing in the VPC for the routes that Cloud WAN advertises through BGP. So very important. Therefore, we recommend those appliances be deployed in the Cloud WAN attachment subnets so that routing is seamless. Now, another feature that was extremely asked for by our customers is appliance mode. Appliance mode allows you to maintain AZ symmetry when you're routing through inspection. Let's see the deployment with Cloud WAN. For centralized inspection, we deploy an inspection segment for each region where we want inspection to happen. We have an inspection VPC. And within the inspection VPC, we deploy the either network firewall or gateway load balancer powered appliances. Very important there, call out from our wizard, the inspection segments are global, but they have a regional attachment only, right? So, how does routing look like? There's segment sharing between the production, development, any other segments that you may have, and the inspection segments. So for ingress, our packet flow will be fairly straightforward. Inspection goes through the network firewall or gateway load balancer endpoints. Return traffic or traffic initiated in the internet also is routed through the inspection appliances. And back to the VPC. Now, what do we do with cross-segment? Here's where the appliance mode feature is very important. We have appliance mode enabled for the VPC inspection attachment. And you observe that the route tables have slightly changed. The reason for that is because we need to maintain symmetry when we're going cross-region. So inter-region, VPC to VPC, cross-segment is fairly straightforward. When we go, this is the return traffic. When we go cross-region, that symmetry is important because if the firewall endpoints haven't seen that traffic in one direction, they will not know what to do with the same traffic in the reverse direction. And here, you can choose if you want to inspect traffic in both regions, so that both firewall endpoints see the traffic flow, or if you want to inspect traffic in just one region. And you can natively integrate Cloud WAN with your TGW infrastructure. This is actually a very interesting integration because not all customers want to migrate from Transit Gateway all their VPCs day one. So you can use Cloud WAN to federate connectivity. You have the route table attachment for Transit Gateway to Cloud WAN. All routing is fully dynamic, so you essentially end up creating a global network segmented using both AWS, Cloud WAN, and Transit Gateway. This also powers your Direct Connect integration with Cloud WAN. So you can natively exchange routes dynamically with Transit Gateway and Cloud WAN and use Direct Connect Gateway for those routes to be advertised on premises. Here I have two segments, production and development, but you can also use a separate hybrid segment if you want to and inspect that traffic. We have a couple of blogs that explain those flows. Now, last year at reInvent, we cornered a new term, application networking, right? And what we mean by application networking is split across two different areas. First is elastic load balancing that powers application delivery, right? And Amazon VPC Lattice, which is providing you not just with that highly available connectivity mechanism, but also with the application features. For elastic load balancing, we released a feature that is very near and dear to my heart, and it is actually powered by that primary IPv6 address on the interface that we talked about at the beginning, which is the ability to have IPv6 instance type targets for application load balancers, network load balancers. And you see here that in order to do that, you have to have that primary IPv6 address on the ENI. Now, from the deployment perspective, you folks are probably very familiar with how application load balancers are deployed. They have a load balancer subnet, and they support dual stack. Very important, we just launched a couple of days ago mutual TLS support for application load balancer. This works by configuring a trust store, attaching the trust store to your ALB listener, and enabling MTLS on the ALB listener. This means that your client traffic is authenticated by the application load balancer, and the application load balancer actually sends all that information back to the targets if you want to configure additional business logic. For more details, there's a full breakout session that talks about application networking and all the features on application load balancers. Now, Network Load Balancer also has a new feature that got launched this year, which is security group support. This, I think, was one of the most upvoted feature requests for Network Load Balancers. Now you have the ability to associate security groups with your load balancer ENIs. Some considerations here relate to the fact that you have to associate those security groups at creation time. Also, you can use security group referencing that we mentioned at the beginning to reference security groups of the load balancer on the targets to make sure that you only allow traffic from the load balancer to the targets. Now, let's go to probably my favorite topic, VPC Lattice. And perhaps some of you are still wondering, well, why VPC Lattice? Well, remember this? This is kind of complex. It's a lot of things that you need to deploy and manage and configure. to get all those nuts and bolts built in together, right? So Amazon VPC Lattice comes as an application networking product that takes a lot of that complexity away, giving you the ability of configuring zero trust service-to-service communication on AWS without worrying about IP addresses and networking anymore. So it creates the network path as well. Let's look at the use cases. And application networking and VPC Lattice are very loved by EKS and Kubernetes enthusiasts, but also by network folks, because they provide not only security features, not only application level features, but also network level features. And I think from one of the features that I'm most excited about with VPC Lattice is that both admins and developers can look at the same configuration and understand it, right? There's no more disconnect between application level folks and network infrastructure. Components that VPC Lattice comes with and powers all these services. Service network is a new logical construct, a new logical boundary. Services that you define that can have a deployment model across all of our compute platforms, so EC2, Lambda, ECS, EKS. When you create services, you can specify multiple target groups, and these target groups can have different compute options. Then you have the service directory. When you create a service, that service appears in the service directory, and you can share services using Resource Access Manager, as well as service networks, using, again, Resource Access Manager to populate service directories in other accounts. And auth policies, authentication and authorization that happens at VPC Lattice level. You can have auth policies associated with your service networks and with your services. Now let's see VPC Lattice in action, and this is my favorite use case. I think probably we're getting this question every day. How do we configure a VPC to have network connectivity that also has overlapping IP space? And because VPC Lattice completely abstracts the network addressing, we'll see how that happens. We first associate services with the service network. Then we associate the VPC with the service network, allowing clients in the VPC to consume the services. We configure auth policies. And we look at the life of a packet. All the VPC constructs that you are familiar with, security groups, NACLs, route tables, still apply. So in order for a packet to go through VPC Lattice, it has to be allowed, right, by all these security constructs. So we start with the packet starting from the client to the service network. Once DNS resolution has happened and the client gets the IP address of a VPC Lattice service, which is 169.254 in IPv4 or ULA address in IPv6, that packet gets generated, and it needs to be allowed by the security group of the source, by the NACL, route table, and the security group on the VPC association. This is one of the most powerful features of VPC Lattice, that it allows you to use security in a layered approach. Right? You don't have to give up on your security groups or on your NACLs or on your route tables, right? You use them complementary. Now, traffic was allowed. It gets into the service network, and at the service network, all the auth policies and the security configuration and the routing configuration are applied. And last but not least, the packet gets to the destination, into the destination VPC, and again, it needs to be allowed by security groups and NACLs and routing. Now, there's a couple of new capabilities for which our CAT is very excited. Support for service targets and shared VPCs. It's been a feature that's been asked by a lot of our customers. General availability of the AWS Gateway API controller for native integration with EKS. This is the powerful integration, native integration with EKS services and CRDs and all the constructs that you have available there. And identity header propagation, SIGV4A, which allows you to do that authentication in remote regions, right? So we propagate that information natively. Now, we've built connectivity. Let's secure it.
Thanks, Alex. So I'm pretty sure Alex just stepped through the whole OSI model from the ground up all the way to application. Pretty awesome stuff. We've got so many features now that you can just, or services that you can just build networking within AWS, but security is still something that's in the heart of everything we do here at AWS. First, let's start with some administrative connectivity. It may sound boring to the users, but as an administrator, it's something that's actually pretty important. So we have this thing called Amazon EC2 Instance Connect. And so basically the idea here is by installing the Instance Connect software on an EC2 instance, you can connect to that instance from the EC2 console. And so here's how it works. Basically, you've got an administrator here on the left going through the console. You have a EC2 instance with a public elastic IP, and then you can communicate with that EC2 instance from the console itself. So you don't have to manage things like handing out SSH keys to users that need to administer instances. Now, there's one flaw in this design, which we worked pretty hard on fixing in the last year. And so the problem was you needed to have a public IPv4 address for the instance. And so that meant public subnets were accessible via Instance Connect. And so what we've recently done is we've released Amazon EC2 Instance Connect endpoints. And so what this means is we now use our endpoint technology to drop connectivity into the VPC, and you can communicate with EC2 instances that don't have public IPv4 addresses. And so no public IPv4 addresses are needed here in this case. Pretty awesome. Okay, as far as networking security, I always think about things like inspection. And so let's talk about inspecting in the VPC. One of the, I guess over the last few years, one of the architectures that keeps popping up when we talk to customers is configuring an egress security VPC. So folks say, hey, I've got this environment, I've got 10 VPCs, I'd like to send everything through something like a firewall. So back in 2020, we released AWS Network Firewall. So basically, it allows for unified management and monitoring. It's a cloud-native traffic inspection mechanism. It's highly scalable, and it has a flexible inspection engine that's built into it. So basically what this is powered by gateway load balancer technology, and we'll talk about gateway load balancer, but you can now have a firewall endpoint in the VPC. That was as of 2020. The architecture looks something like this. So you've got an EC2 instance, you would route via the AWS network endpoint inside the subnet onto instances, or maybe out into the internet gateway. You can also have something like a NAT gateway in line as well. So now you're going through a network firewall, through a NAT gateway, and then out into the public internet. Now the beauty of both NAT gateway and network firewall is they're managed services. They're both scalable. And so you don't have to worry about spinning up more instances to handle more traffic as you send more instances to the network firewall, or in this case, NAT gateway as well. Now there's a whole bunch of other deployments that you can actually do with network firewall. This is just one option, really. Now, recently, we've also released IPv6 support. You'll notice that that's a trend in a lot of the services that we're doing. So we released v6 support. So in this case, you could have a v4 subnet, a dual stack with v6 and v4, or a v6 only subnet for your network firewall endpoints, which v6 only is actually quite important to customers, where we speak to folks that say, hey, we're using RFC 1918 addressing inside our VPC environment. So your 10s, your 172s, et cetera. But then they say, we've got so many VPCs that we're running out of RFC 1918 addresses across both our AWS environment and our on-premises. And so having the ability to deploy services like Network Firewall in a subnet that only consumes v6 addresses is important to those folks. So they're not burning more v4 addresses, which they don't really have. We also have inbound TLS inspection now for Network Firewall. And so basically integrating with AWS Certificate Manager, we can decrypt TLS traffic, or you can configure TLS inspection on the Network Firewall as well as There's a few considerations here for inbound TLS inspection, and we have outbound TLS inspection for network firewall as well. So we're building these capabilities into the network firewall, and you'll see these types of capabilities built across network firewall, a gateway load balancer. They're basically part of the same type of family, given that network firewall is built upon gateway load balancer underneath the hood. Speaking of which, so gateway load balancer is really the ability to implement third-party appliances inside your VPC for things like inspection. And so that was where we released this in 2020 as well. We wanted to say, hey, you can use AWS Network Firewall, but if you like or use existing firewall vendors, you can use those in your VPC as well. So that's where gateway load balancer really comes into play. And so basically, it's a fault-tolerant, highly available infrastructure that you deploy and manage in a VPC that you own and manage with gateway load balancer and gateway load balancer endpoints inside a VPC. And so it looks something like this, where we've got a VPC on the top here with a gateway load balancer endpoint. Traffic might be going from one instance to another, but in this case, we're actually routing via the gateway load balancer endpoint. So we're sending traffic down to a gateway load balancer in another VPC, and then sending or flow hashing that traffic via Geneve across appliances inside the inspection VPC on the bottom here. Now we also have V6 support for gateway load balancer as well. So hopefully we can get V6 everywhere. That would be a great scenario. Now there's a couple of considerations here. So with gateway load balancer, basically from the gateway load balancer to the appliances, we use what's called Geneve in tunneling encapsulation. So in this case, we're actually sending V6 inside the V4 Geneve tunnel towards the appliances themselves. So this is something that you would work with your appliance vendor to say, hey, firewall vendor, we'd like to use this within our VPC, and you'd use their service as the EC2 instance or their software, and then the gateway load balancer would be managed by yourselves. Okay. Now let's talk about VPN-less application access. So the VPC itself is basically, I think of it like a walled garden. And I think that's why customers love it so much. They say, hey, I've got this VPC and that's my perimeter. Now, you'll probably never hear me say VPC is a security mechanism, because it really isn't. It's everything else that goes into it. But it is a control mechanism. And so when you VPN into a VPC or you connect a direct connect, you're extending that walled garden out to applications on premises. And so what customers were asking for was the ability to connect on an application-by-application basis into the VPC or to the applications, essentially zero trust network access to applications inside a VPC. So I think, was it this year we GA'd verified access? So
same with VPC Lattice.
Same as VPC Lattice. We announced it last year at reInvent, but a few months ago we went GA for verified access. And basically the idea here is we have a verified access service sitting in front of the VPC connecting two services. And it actually looks something like this, where you've got applications, you've got an application load balancer. Great, applications and application load balancers go hand in hand. But we're also now able to front end that with the verified access service. And so that integrates with identity providers and also WAF. And now users actually through a user agent on a browser will connect through verified access through to the application itself. So now you've got application by application access into the VPC without giving access to the whole VPC like you would from a routing and security group basis if you direct connect or VPN'd to that VPC. And you'll notice here the extension of this diagram. We're using Hyperplane as well for these services. So Hyperplane ENIs are a very common thing that you'll see as part of these services and how they're deployed within VPCs. If you want to learn more about Hyperplane, come and chat to us after the talk. We can send you to a few talks that talk about that. Now this is 2023, and so...
We had to. How could we not have a generative AI section in this talk? So networking and generative AI, let's talk about that. So back in, I think this was 2010, I might mess up my years a little bit here, but we had the C1 instance, which gave you 1 gigabits per second. I remember this. I remember thinking, man, you can have a virtual machine or EC2 instance that has 1 gig. Then
A little bit later, we released the CC1 instance. I think this is for clustered computing. We had, basically, we could do 10 gigabits per second. And we kind of extended that out in 2013 and I think 2015 for the C4s for 10 gigabits per second with enhanced networking, which gave you more packets per second, and then EBS optimized by default. So the EBS storage was optimized as well. And we kept going from there. So C5s, which I think was in 2015, C5Ns, which was our network optimized instance at 100 gigabits per second. Imagine that. I used to manage an internet backbone for an Asia Pacific country, and we had 80 gigabits per second for the whole country. And now you can have a C5N instance. And I think this was around, what, 2016, I think it was, 2016. Amazing stuff. Then we just kept going from there. 200 gig with a C7GN. By the way, these slides and the boxes are kind of to scale. So you can see the difference between the instances bandwidth across these instance families. In 2020, we released the P4D. This was a cloud-first 400 gigabits per second per instance. And so that was when we built what we call Ultra Cluster 1.0. It's a great talk by Stephen Callahan. We call him Steph Cal, but you guys don't know who Steph Cal is. It's available on YouTube. Check it out. He talks about the ultra cluster architecture. Super interesting stuff. But basically what's happened is for generative AI or large language model training, we've started building dedicated clone networks in not just data rooms, but data centers and campuses of P4D instances so that we can allow our customers to come in and train large language models. And so that's where the AI ML workloads really came into play. In TRN1 was, I think, 2022, 800 gigabits per second, and it's just gotten crazy. TRN1N was this year, I think, 1600, P5, 3200. A couple of days ago, TRN2, 6400 gigabits per second per instance. I haven't had the honor of spinning one of these up yet and trying to do it.
I think it's going to be expensive.
Probably. I might get a note from a manager about, hey, what's going on with these TRN2 instances? What are you up to? We'll see. Now, those other instances are still on this slide, by the way. They're there. They're just really, really, really tiny in comparison. They're like way down there. So anyway, we're enabling generative AI through networking and instances that can support that kind of networking. And with our Ultra Cluster 2.0 architecture, we've basically got a whole new network design that we build our clone networking in our data centers. And so we've flattened and widened our data center networking to allow this kind of connectivity. We've got 10x bandwidth with non-blocking capacity through our data centers. And we've also, again, the Stephen Callahan talk, check it out. We've got our own routing protocols now. I think we call it CIDR, where we're replacing things like BGP and OSPF in the data center because they just weren't functioning in the ways that we wanted. It's amazing stuff. Now, what does that mean for you folks? Well, we've also built this protocol called SRD, or Scalable Reliable Datagram. I think we released that last year. Yep. We call it ENA Express. And so if you look at a data center, a typical path looks like this. You could get some hotspots with TCP flow hashing. We now do basically this. Oops, that's a build out. We do this where we flow hash flowlets through our data centers. Pretty amazing stuff. And you don't need to do anything. It's just an instance that supports SRD or ENA Express. And this year, we've actually expanded that by 58 instance types. And so this is pretty huge for customers that want to get access to this type of technology. Pretty amazing stuff. Okay, so now we get into what it looks like from a customer perspective, queue support or network troubleshooting. This is amazing. I'm super excited by this. So we've got an architecture here, and things are broken. So the network doesn't work. And so we can't SSH to instances in AZ1. App servers can't talk to each other. Let's jump in there and let's ask queue. And so basically, this is now in preview, so you can check this out yourselves. On the right-hand side of your console, jump in on that little widget. You'll get a nice little text prompt here, and you can basically ask questions. Like in this case, we're going to ask, why can't I SSH to my web server in AZ1? And so basically, to get access into the queue for network troubleshooting console, basically it'll say, hey, looks like you're trying to do some troubleshooting here. Let's check out the preview experience. Alex, you've played a bunch with this tool over the last couple of weeks.
I did. And you should check out the blog post. We talk about why you can't SSH into your EC2 instances and why your app doesn't talk to the database with the help of Amazon Q. So the integration with network, for network troubleshooting with VPC reachability analyzer is essentially showing us a lot of interesting things that when we started playing with this, we had no idea that they were there. We just got a VPC that was configured, and we were tasked with solving these issues for the network blog post. So check it out. So we've asked Q why we can't SSH, and Q is actually running VPC reachability analyzer behind the scenes. It understands what we're asking it about, right? App servers, why can't I SSH into it? And it shows us the troubleshooting steps that we need to take. It shows us the actual security groups that don't have anything configured in them. And for database access, it also shows us why the app can't talk to the database. So we ask it again, and it tells us after a couple of seconds that we have a network ACL that is not properly configured. So that being said, we've solved the network issues with Q. Go read the blog and let us know what you think about it. And now that we've solved the network issues, a couple of considerations, you'll find them as well in the blog. This is preview, so you have a number of questions that you can ask it, and it resets every 24 hours. Thank you. Thank you.
Yeah, we're out of time. Thanks for joining us.
And don't forget to fill out the survey.
Oh, next slide.
The survey.